All right, I'm your man, John Wilson, and we've got a good one for you today.
Today, we are going to start Module 8, Solving System of Equations by Graphing. We will understand that solutions to a system of two linear equations in two variables correspond to points of intersection of their graphs because points of intersection satisfy both equations simultaneously. Okay, so here we have a system of equations. Unlike what you've seen so far, where we just have one equation, now we have two equations together. And what we're looking for is the solution to both equations. There will be one coordinate pair. Our solution for a system will always be a coordinate pair. There is a coordinate pair somewhere in the universe that solves both equations simultaneously. That means at the same time. Now, in order to solve systems of equations, there's a couple different ways we can do it. The very first way is to solve a system by graphing it. And when we graph a system of equations, the solution is going to be wherever the two lines intersect each other. That means that wherever they cross over each other, that coordinate pair, that one specific point, is going to be the solution to that system of equations. Now, if you guys remember back from like Module 5, when we graph equations, we want to put them in this form. Y equals mx plus b. You know what that's called?
Slope.
That's called slope-intercept form. We want to put them in slope-intercept form. Now, looking at these two equations here, are both of these equations in slope-intercept form, yes or no? Let's see. Y equals mx plus b, yeah, first one's good. And then the bottom one, y equals mx plus b, yeah, they're both good. Since they are both in y equals mx plus b form, now all we have to do is go in and identify the slope and the y-intercept, and then we can go and graph these equations. And keep in mind, we are looking for the point where the two graphs intercept or cross over each other. Intercept, wherever they cross over each other. Do you guys have this written in?
Yeah.
Yeah? Yes, no, maybe?
No. I can't see that part.
Y-intercept. Y-int. Okay, so we got to identify the slope, the y-intercept. Still the same problem. We're going down on your notes to the next slide. All right, so we want to look at the first equation. The top equation, we have y equals 3x minus 2. Looking at that equation, Brianna, looking at the top equation, what's the slope there? The slope is 3, because it's the m, the number next to the x. That's my m, that's my slope. And then, Brianna, what's the y-intercept? -2. Okay, so we have the slope, we have the y-intercept. Now, remember that when we graph an equation in slope-intercept form, we always graph the y-intercept first, and then we use the slope to find the next point. So once you identify the y-intercept, you're going to graph that point right away. You are then going to use the slope to get to the next point, and the next point, and the next point. Now, how many of you remember, when we are trying to use the slope to get to the next point, we need our roadmap, right? What do we have to do to the slope? We have to turn into a what?
A fraction.
We have to turn into a fraction. Unless it already is a fraction. If it already is a fraction, that's great. We don't have to do anything. Is the slope a fraction right now?
No.
No, it's a whole number. So we want to turn that slope into a fraction. And doing that, what is 3 as a fraction? 3 over 1. Now that we have our y-intercept and we have our slope as a fraction, we can go in and graph this equation. We will then repeat that process for the second one. Well, let's graph the first one. I'll use blue, and then I'll use red for the next one to show those two different lines. So remember, we graphed the y-intercept first. What was my y-intercept for the first equation again? -2. That's the slope. That's the y-intercept, -2. So I go to the origin, and since my y-intercept is -2, am I going up or down?
Down.
Down. Down how many spots? 2. That's -2 on the y-axis. That's my y-intercept. That's the point where this line will cross over the y-axis. To get to the next point, does everyone understand how I got the y-intercept?
Yeah.
Yeah, remember this? Okay. So now to get to the next point, I look at my slope. Let's see if it remembers. The numerator tells me to do what? Go up, down, left, or right?
Up, down.
Up or down. Now, because it's positive, what are we doing? We're going up 3. The denominator tells me to go right or left. Because it's positive, what am I doing?
Right.
I'm going right. Okay. So once we have our y-intercept plotted, we then go to our y-intercept, and to get to the next point, I'm going to have to go up 3, 1, 2, 3, and then I have to go right 1 spot. And then I repeat the process. I go up 3, 1, 2, 3, right 1 spot, Because the next point would take me off the graph, I'll just stop right there. And I will go in and I will connect these points with a line. I won't draw the arrows yet. It would help if I actually put the line in the right spot. Alright, so that is our graph so far. So we graphed the first system. Once I have the first system graphed, or once I have the first equation graphed, I want to go in and I want to graph the second equation, y equals negative 2x plus 3. Because we're looking for what? What are we looking for? To solve this system, what are we looking for? We're looking for where the two lines intersect each other. So we're going to go in, we're going to graph the second equation, y equals negative 2x plus 3. What's the slope for that equation, guys? Negative 2. And then what's the y-intercept? Positive or negative?
Positive.
Positive 3. Okay. So we have our slope is negative 2. We have our y-intercept at 3. We need to turn the slope into a fraction. So, Chris, what is the slope going to be as a fraction? Okay, the slope is negative 2. The y-intercept is 3. What will the slope be as a fraction? I have to turn it into a fraction in order to use it to get the next point. No. The y-intercept, look at this equation. I want you to just look at this equation. That's my y-intercept, the 3. My slope is what? What is my slope? Negative 2. Okay. The 3 has nothing to do with the slope. We want to turn this into a fraction. So what would negative 2 be as a fraction? Okay, but it's negative 2. What would it be as a fraction? Negative 2 over what? Over 1. Make sure that you leave your denominator positive, because a negative and a positive make a negative, and this is a negative 2. So it'll become negative 2 over 1. It's not going to be written there, though. It's going to be written down here, and it's going to be negative 2 over 1. All right, Chris, I'm going to stay with you for a second. We want to graph this. So what was my y-intercept again? No, that was my slope. What was my y-intercept? No, my y-intercept is not a fraction. My slope is a fraction. My y-intercept in this case is a whole number. Looking at this equation, what is my y-intercept? 3. So I want to graph that. That means that I'm going to go to wherever y equals 3. I start at the origin. Am I going to go up, down, left, or right? Up. Just the person I'm speaking to, please. Just that person. What am I doing? Up. I'm going up. Not left, not right, not down. It's a positive 3. I'm going up. 1, 2, 3 spots. And I'm going to graph that point right there. Okay. So I got the y-intercept graphed. Sean, how do I get to the next point from there? Okay, Sean, what's your slope? Sean, what is your slope? What's your slope? My slope's negative 2. What's my slope as a fraction? Negative 2 over 1. Okay, so let's repeat what we just set up here. The numerator tells me whether or not to go up or down. And just Sean, the numerator here is negative. So what does it tell me to do? Up or down? Down. So I'm going to go down 2 spots from the y-intercept. And then the denominator is positive. So am I going to go left or right? Right. How many spots? 1. Okay. So you go to the y-intercept that you just plotted for that equation. And from here, what are we doing again? Down 2, right 1. And you put the point. You repeat the process. Down 2, right 1. Down 2, right 1. Down 2, right 1. I didn't really need to go that far. All I needed to find was the point on the graph where they intersect. I've already found that. I'm now going to connect these points with a line. I'll make that line red, just so we can see the contrast. And then let me ask you a question. Did we find the point where the two graphs intersect each other? Yes or no?
Yes.
Yes, we did. This coordinate pair, our answer, once again, our answer will always be a coordinate pair for a system of equations. So that answer is going to be what, Chris? What's my answer going to be? What is the solution to this system? Can you identify that coordinate pair? Alright, so remember to identify a coordinate pair, Chris, we start here at the origin, and we're trying to get to this point where the graphs intersect each other, right? So to get from here to here, we always go right or left first. What am I doing? How many spots? 1. So that's 1 on the x. And they get from here up to here, am I going up or down? How many spots? 1. So that's positive 1 on the y. So your solution for this is 1, comma 1. That is your solution. The graphs intersect at 1, comma 1. That solution is a coordinate pair. The answer to this problem, the solution, is 1, comma 1. Whenever you're solving a system, you will never answer it as x equals 4 or y equals 6. Your answer will always be in the form of a coordinate pair. In this case, your answer is 1, comma 1. You will get a lot of practice graphing when you solve systems this way. So in case you forgot anything from the previous modules, this will give you the chance to go back and fix it. Any questions on this first one? No? What's up?
How do you know whether it goes right or left? So like going down and then go right or left?
Okay, because the numerator, if it's positive, tells us to go up. If the numerator is negative, it tells us to go down. The denominator, if it's positive, we go right. If it's negative, we go left. All right. And no questions on this one? What's up? Good. I was waiting for somebody to say it before I moved on here. Put the arrows. Don't forget. This is a graph. You got to put the arrows there. You got to put the arrows here. Boom. Boom. Okay. And there we go. That one's done. Jennifer, what's different here between this one and the one we just solved?
The Y-intercept. Oh, there's the Y has plus it added plus 4x.
Yeah. This first equation is in slope-intercept, yes or no?
Yes.
Yes. What about the second equation, guys? Is that in slope-intercept?
No.
No, it's not. I cannot have the x on this side. So before I can graph this, I have to put this in y-intercept form. To do that, I'm going to go to this equation, and I'm going to use the exact same thing that we were using in Module 7, inverse operations, in order to get y alone. Now, even though there's no x on this side, I can still move the positive 4x over to the right by performing an inverse operation. So what is the opposite of a positive 4x, guys?
Negative 4x.
Negative 4x. So to get y alone, I subtract 4x from both sides. These 4x's will cancel, and I bring down y equals negative 4x plus 1. When you are presented with an equation that is not in the correct form, you must go in and rewrite it first before we can graph it. If you try to graph this, it's going to be wrong, because you might think here, okay, well the 4x, that's my slope, that's a positive 4, but when we actually rewrite it, what's the actual slope?
Negative 4.
Negative 4. There's a big difference between a positive 4 and a negative 4. What's up? Question, Connor?
Yeah, you subtracted negative 4 from the empty space. Negative 4.
Yeah, because I don't have any variable terms on the right side, do I?
No.
So I just subtracted negative 4x from empty space. I can't subtract negative 4x from 1 because 1 is a constant and 4x is a variable term. So I'm just moving it over. But technically, yeah, I'm subtracting 4x from 0x. That gives me negative 4x. All right, what's up?
Why would you get negative 4 though?
Because this is a positive 4, right? What's the inverse of a positive 4? Negative 4. So I subtract 4x from both sides. These cancel. I have to do that to get rid of it from here. And I have y equals negative 4x plus 1.
Will it just be like I just switch the numbers or something?
It depends on what problem you're being presented with. So it all depends. Now there's lots of different things we could do. You could have something like this even. You could have something like 2y equals, no, let's rewind this. 2y minus 6x equals 12. You don't have to write this, but I want you to pay attention. Your eyes should be up here. You shouldn't be doing stuff like coloring in a ticket or something like that right now. Now to get y alone here, it's going to be a two-step process. What has to move, first of all? Sean, what has to move? Okay, but we need to get y alone. We should end up with something like this, y equals. So what's the first thing that we need to remove from this side? No, this side.
2y.
No, we want the y over here. We want it. We don't want to move the y unless we have to. We don't have to move the y. So what do I need to get rid of from this side of the equation? The negative 6x. So what's the inverse of a negative 6x? Good. So we're going to add 6x to both sides. Boom, boom. We add 6x to both sides. We'll bring down the 2y. those will cancel, and I'll have 6x plus 12. You guys understand how I did that? Yes or no?
Yes.
Yes. Does anybody have any questions on how I did that? It's the same stuff we've been doing. You're not subtracting, you're not adding 6x to 12, because this is a what? What is this again?
Constant.
That's a constant, and this is a variable term. Coefficient, but this is a variable term. You cannot subtract, you cannot add 6x to 12. If this was 12x, yeah. But because that has a variable, and that's a constant, you cannot add, subtract, or anything like that to those. What's up?
Do you leave the 2y?
Oh no, we're going to deal with that in 1 second. What's up? Yeah. So now, I have a 2y. Can I have a 2y?
No.
No. So, what's happening between the 2 and the y? Multiplication. Same process. These are all rules you know. What's the inverse of multiplication? Division. So I'm going to divide both sides by the coefficient. Divided by 2, divided by 2. Please pay attention here. So when you get to this on your classwork, you have already seen it. You know what you're doing. What happens to the 2's?
Cancel out.
They cancel. You're left with y. That's what we wanted. And then we do these one term at a time. What's 6x divided by 2? 3x. What's 12 divided by 2? 6. And now we have it alone. I can graph that. I cannot graph this, but I can graph that. What's up?
Why do you divide the 6 as divided by 2 with 3?
As I'm getting rid of the coefficient, what I do on one side of the equation, I must do on the other. I divided the entire left side by 2, so to keep the equation equal, I have to divide the entire right side by 2, all right? Same theory as multiplying both sides. Remember when we were trying to get rid of the fraction? In the previous module, we'd multiply both sides by the least common multiple. Same thing, you're multiplying both sides. Here, we're dividing one side by 2, so I must divide everything on the other side by 2 to keep it equal. So this equation and this equation are actually the exact same thing. If I were to plug in, if I were to substitute in a certain value for y and x, I would get the same thing here as I would down here. You would, because these equations are completely equal. They're just written in different forms. This is technically written in standard form, which you'll come to find out later what that is. This is written in slope-intercept form. Anyway, back to this. Okay, so you understand how we rewrote this, right? Yes, yes or no?
Yes.
Yes. Now that we've rewritten it, and we have negative 4x plus 1, I can go in and I can graph these. Shimon, what's the slope of the first equation, the top one? The top equation, the first equation on the top. So my slope is negative 2, and then Corey, what is that as a fraction? Corey, sit up for me. What is that as a fraction? The slope for the first equation. Yeah, what is that as a fraction? Good, so it's negative 2 over 1. And then let's go to, Ali's not here. We're gonna go to Connor. Connor, what's the y-intercept for that equation?
3.
3, okay. So let's go in and let's graph this line right now. Yellow. I go to the origin, tell me, I'm graphing my y-intercept. What am I doing, up, down, left, right?
Go down to
I'm graphing the y-intercept first. Remember, we always graph the y-intercept first. So what's my y-intercept? My y-intercept's 3. So starting at the origin to graph the y-intercept, what am I going to do? I go up how many spots? 3. 1, 2, 3, and I graph that point. Okay? Now to get from here to the next point, I look to my slope. And Mabel, how do I get to the next point? We always go up or down first. So looking at the slope, am I going up or down? Down how many? Down 2, and then right 1. Yeah, this is negative, so I go down 2 and I go right 1. Down 2, right 1. So I go to my y-intercept, I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Let me back this out a little bit. And I will connect all these points with a line. Don't draw any arrows yet. You'll see why when I get there. So we'll connect all these with a line. Okay, so we got the first one graphed. We need to do the second one now. Let's go to calculus!
Okay.
Question, homie. Second equation, what's my slope?
Negative 4x.
What's the slope? Just slope.
4.
Negative 4. Okay, slope's negative 4. What is that as a fraction?
Negative 4 over 1.
Negative 4 over, I'm drawing with lines. Okay, negative 4 over 1. Lucas, what's the y-intercept?
Y-intercept is 1.
Y-intercept is 1. Positive or negative?
Positive.
Positive 1. Okay, so I have my y-intercept at 1. I always graph the y-intercept first. Maria. Corey, please sit up for me. Maria. I want to graph the y-intercept. So starting at the origin, am I going up or down?
Up.
I'm going to go up. How many spots?
1.
1 spot. So I'm going to go up 1 spot, right there. And then to get to the next point, what am I doing?
You're gonna go down 4.
I go down 4, and then
You're gonna go on right 1.
right 1. So down 1, 2, 3, 4. Down 1, 2, 3, 4, right 1. Down 1, 2, 3, 4, right 1. And I will connect those points with a line temporarily. And then, let's examine what happened here. Looking at the graphs of these two lines, guys, what's happening to them? They're getting closer together?
No.
No, what are they doing?
Separating.
They're getting farther apart. But as we look at this side of the line, they're getting farther apart. But what's happening here as we go this way?
Getting
They're
closer.
getting closer together. So this looks like it's going to be one of those instances where we're going to have to reverse out the slope, and we're actually going to have to graph the lines this way in order to figure out where they intersect. So let's revisit our slope here. Remember that when we reverse out the slope, all we're doing is switching the positive or negatives of these values. So where here, my numerator is -2. When I reverse the slope, what's the -2 going to become?
Positive.
Positive 2. Here, my denominator was 1, so it's going to become -1. Let's do the same thing down here. So this was -4, it becomes
Positive 4.
+4. And this was 1, it becomes
-1.
-1. Perfect. So let's go backwards and let's try to finish this up so we can get our solution. So I'm going to go here and I will regraph this line. Now I'm going the opposite direction. So Santana, what am I doing now?
You're going down.
No, it's changed now.
Oh wait, no.
So I'm going up 2 and then
The left one.
left 1, up 2, left 1. Okay. And then we're going to go to the other one. Question?
You would still start at the one.
I still always start at the y-intercept. You always put the y-intercept first. You always start at the y-intercept. You could start down here, but you're going to end up in the same spot, right? Up 2, left 1, 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 up 2, left 1. But you would always start at the y-intercept. So when you reverse out the slope, start at the y-intercept. Let's do it to the other line now. So, Tavares, to get from here to my next point, what am I doing now? We're graphing this one.
You go
Up 4. 1, 2, 3, 4, and then
You go right 1.
is this positive or negative?
Oh, yeah.
So I'm going to go
Left.
left 1. So up 4, left 1, up 1, 2, 3, 4. That would take me off the graph. So I will stop right there and I will go in and I will reconnect my lines now. And that's green all of a sudden. Let's reconnect this. And can I get the same type of slope here? And perfect.
It like curves, right?
I don't know, it looks like it. It might be like, it actually doesn't curve because these are, what type of functions? Sorry, what type of equations? Linear equations, so it'll be a straight line. And we'll go in and we'll do the other one now. And let's go, let's fix this. Let's see if we can figure out where these two lines intersect each other. Help out graphing at the same point. Looks like right about there. And then we'll get rid of this line. Oh, not that line. Get rid of you. You come back over here. And we'll drop you right about there, just so we can see the solution. All right, do we see a solution here, yes or no?
Yes.
All right, so I see the solution. Emily, you have a question?
Yes. Do you always have to like it connect?
You always have to find the intersection of the two graphs. Now, the only time you wouldn't have to do this is when we get all the way to the end of this module, when we solve systems that have one solution, when we solve systems that have no solution or infinite solutions, that's a different case. But for regular systems, you will always have to figure out where the two lines intersect. That's the only way by graphing you can find a solution. So we reversed our slope, and now I see a solution. Madison, what's the solution?
4, follow -1.
Okay, so to find this, let's make sure we get the right point. We start at the origin. We always go left or right first. So to get from the origin to the solution, are we going left or right? Left. How many spots?
1.
1. So it's -1 on the x. You always do the x value first. -1, comma. And then to get from here up to here, how many spots do I have to go up?
4.
Let's count that to make sure. 1, 2, 3, 4, 5. Positive 5. So my solution to this is -1, comma, 5. Any questions on this one? No? No questions? No questions at all? Just make sure your graphs are nice and as straight as they can possibly be. No questions? No? Okay.
You draw a line? Or you arrows?
Okay, there we go. Once again, still waiting. Still waiting. And there we go. One little arrow. One little arrow. One little arrow. One little arrow. Okay. 4, 3, 2, 1 on this, please. So now the very last thing we're going to do is we are presented with real world problems and situations. Now unfortunately here, the system of equations is not given to us. So before we can go in and graph the system to find the solution, we first have to write the equations. When you are writing systems of equations from word problems, you're generally going to be asked to write 2 types of equations. One equation that adds up the total number of items bought, purchased, sold, something like that, and another equation that represents the cost. So we read this scenario. Actually, we don't read it. I'm going to have Rachel Thomas. Can you read the scenario for me?
Keisha and her friends visit the concession stand at a football game. The stand charges $2 for a hot dog and $1 for a drink. The friends buy a total of $8. Tell them the hot dogs and how many drinks they bought.
Okay, so Kesha and her friends visit the concession stand. They're at the football game. They were at the Dolphins-Giants game last night, right before that.
Yeah,
They
that's
before
not
yarder. Touchdown, wide open. Now the stand, I don't know what kind of stadium this is because I know Sunlight doesn't charge that, but $2 for a hot dog, $1 for a drink. It's like $20 for a hot dog, and it's like this little scribble thing. Anyway, now the friends buy a total of 8 items for $11. We want to find out how many hot dogs they bought and how many drinks they bought. In order to answer that, we are going to have to write a system of equations and solve it. The very first equation that I'm going to write is going to be one that tells me how many items they purchased in total. In order to write that, what are we talking about here? What do they buy? Hot dogs and drinks. So I need to assign a value to each of those things. I'm going to say that hot dogs will be my x. No, I'm assigning. You have to assign variables. You always have to assign variables. I'm going to say hot dogs are my x. What happened? Wouldn't matter. No. You could reverse it, and you'd still end up with the same answer. So, hot dogs are my x, drinks will be my y, and if we add those together, x plus y, it should equal how much? And not 11, the total number of items purchased, which is what? 8 items. They bought a total of 8 items. We just don't know what they bought yet. So if I added up the hot dogs and the drinks, not that I know what they bought, they should equal 8. Okay, so I have my first equation for the total number of items purchased. Now I need one for the cost. Connor, looking at this scenario, how much did a hot dog cost?
$2.
And what variable represents hot dogs? X. So 2x plus. Dylan, what do the drinks cost?
The drinks cost $1.
The drinks cost $1. Okay, so what am I going to write to represent drinks then?
1y.
1y. And then Mr. Mota. If I add up the cost of the drinks and dogs, what should it equal? $11. So that's my system. X plus y equals 8. 2x plus 1y equals 11. I will now go put these in slope-intercept form and graph them in order to figure out how many dogs did they buy, how many drinks did they buy. You guys have this all written down?
Yes.
Okay. If you look, we're going down to the next part of your notes. You see that the equations are already here for us. Okay, that's great. Can I graph these yet? Mr. Nieto, can I graph these? Yes or no? Can I graph those 2 equations right here? We're on the next slide down now. Can I graph those right now?
Yeah, you can graph the one on the bottom.
I can graph this one?
Yeah.
That's in slope-intercept form?
Oh wait.
Remember, slope-intercept form, you have to have just the y alone by itself, right? So are either of these in the correct form right now? No, they're not. So we have to rewrite them. So, we're going to draw a line here. Juan, what do I have to get rid of here? Remember, we're trying to get the y alone, so what has to go bye-bye?
X.
The x. What's the opposite of a positive x?
Negative X.
Negative x, so I subtract x from both sides. Bam! Y equals what?
Y equals
What comes down?
negative A.
Negative 1x, or just negative x. We'll say negative 1x plus
8.
8. All right, I can graph that now. All right, I need to go finish the other one. Flash! Oh, savior of the universe! What do I have to do the other one?
First, find the coefficient of 2x, and then
Okay, well, we'll draw a line. I need to get y alone. One y is the same as just y, right? Okay, so I know that I'm going to put y here somewhere, but what has to go bye-bye from this side?
with
The 2x. So what's the opposite of positive 2x? Negative 2x. All right, we subtract 2x. We subtract 2x. Those will cancel. Bring down the y. Bring down the negative 2x. And that is plus 11. Can I graph those equations? Yes or no?
Yes.
Yes, I can. I have them both in slope-intercept form. I'm going to go in now. I'm going to graph them. Bolaños! Top equation. What's my y-intercept?
8.
8. So we go 1, 2, 3, 4, 5, 6, 7, 8. That's my y-intercept. And then what is my slope for the top equation as a fraction?
Negative 1 over 1.
Negative 1 over 1. So this tells me I have to go down 1, right 1 to get to the next point. Let's do that. So we start here. What am I doing again?
Go up 1 and then, down 1 and then right.
Down 1, right 1. So down and right, 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 down and right. I went down and right 8 times. Found me 8 points along this here line. And I'm going to connect all those points with a line. Just like that. Now that I have one equation graphed, I have to go in and graph the other equation. Alicia! What is the y-intercept was the other one, yeah? 11 is my y-intercept. So I know that the first y-intercept was 8. So to get to the other one, I go 9, 10, 11, yeah? And I put my y-intercept right there. Okay. Corey! What is my slope as a fraction?
What?
What is my slope as a fraction, yeah?
Negative 2 over 1.
Negative 2 over 1. Okay, so it's negative 2 over 1, negative 2 over 1. That means that I have to go what? Negative 2 means I have to go down, down 2, and then right 1. All right, let's do that. Down 2, right 1, there's a point. 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 All right, now we're going to take all the points right now. We're connecting points with a line. I like a line, nice straight line. These are linear functions. It can be a nice straight line going down. Did I find the point of intersection, yes or no?
Yes.
Yes, I did. That point of intersection is, hold on, let's just go to, Matthew, what's the point of intersection?
You're not gonna forget anybody else? Alright.
What's the point of intersection, bud?
3,4.
Let's check that out. So, we start here at the origin. I want to go from here
5.
to here. So, I'm trying to go from here to here, right? So, starting at the origin, how many spots to the right do I have to go?
Huh? Oh, 3.
3. So that's going to be 3, comma, and I have to go up 1, 2, 3, 4, 5. 3, comma 5. Do you know why that answer makes sense?
But
do you know why it makes
it's
sense?
there.
Well, it's 3, comma 5, but
Well,
go back a
answer.
second. How many items did they buy in total?
11.
No, how
Or
many
no,
items?
8.
They bought 8. So 3 plus 5 should equal
8.
8. If you got something else like 2, comma 7, that would be 9. That would be wrong. So the answer in the context of this problem means that X is hot dogs, Y is drinks. They bought 3 hot dogs, 5 drinks. That's it. Sydney, what's up?
There's multiple lines of intersection. Like on the same line,
What happened?
right? Isn't there multiple
Points of intersection? The only point of intersection for this system is right there at 3, comma 5. If you have something in y-intercept form, that means that it's a linear function, right? So that means they're both going to be straight lines of some sort of form, so they can only intersect in one particular spot. If we were to zoom all the way in, we just take this, zoom in, we would see that although there's points all around it, the only point where they actually cross each other is exactly at 3, comma 5. What's up? Put you in? Didn't I? I did? I'll keep it for being honest. There you go. Okay. Yes?
What kind of goes first?
As soon as the whiteboard's done. Okay. Sorry, video, we have to edit this part out because apparently Corey forgot that we don't ask that question while we're filming. Corey! You know better. Alright. Just in the middle of the video. One more question to go for the day and for technically until break. Last question until break, kids.
Yay!
No, there's still questions for the quiz next class.
Last question on the slide.
Oh.
Get with the program.
I apologize, video, but we have to edit that part
Oh my
as well.
god.
Okay. Last scenario here. Chris said he wants to read it. So, Chris, can you read that for me?
A friend they will wear either a baseball cap or a shirt imprinted with their logo while working. They want to spend exactly $36 on a shirt and caps. Shirt costs $6 each and caps cost $3 each.
Okay, so we got Ocho Amigos Incorporated. We got 8 friends. They started a business. Each friend is either getting a baseball cap or a shirt. Okay, so they're not getting both. They're getting a baseball cap or a shirt with their logo. We don't need to know about the logo. We don't care. We just know that each friend, there's 8 of them, is getting either a cap or a shirt. Now they want to spend exactly how much? $36. Lots of information here. Shirts cost how much? $6, and caps cost $3. So we need 2 equations. One equation, the first one, for how many items they're going to buy. Second equation, how much it is going to cost. We are going to let x equal the shirts, y equals the caps. So the first equation for the total number of items they purchased should be x plus y equals, no, how many friends? 8. Altogether, they're only going to buy 8 things, because each friend is either getting a shirt or a cap. They are not getting both, because apparently the Ocho Amigos Incorporated kind of cheap. Alright. So, Ocho Amigos Incorporated, we now have the equation for how much they're going to buy. We want to find the equation for how much the cost of this whole thing is going to be. Looking back at the scenario, how much does the shirt cost? 6x. There we go. 6x plus 3y, because caps are $3. Altogether, they only want to spend $36 because Ocho Amigos Inc. is kind of cheap. So, we have our 2 equations. What would be the next step? What would be the next step, Emily? Go to the next slide. Okay, that's a good idea. That's correct. We must blank the equations in blank form. What goes there? Emily, this is for the $1 million. Do you know what blank and blank is? You don't know? Oh, sorry.
How do you know?
That's not the correct answer. We're looking for something slightly different. Gunner, what goes here?
Right.
We must rewrite. Ooh, so close. Sorry, no millions for you. Anybody want to know what goes here? Yes, Francesca.
Slope intercept.
Oh, she got it. She wins $1 million. Congratulations. Hope you don't mind IOUs. All right, so we must rewrite the equation in slope-intercept form. The first equation was x plus y plus. That's like horrible looking for us. You know I'm going to erase it. I am slightly OCD. X plus y equals 8. That's good. Now it's still horrible, but anyway. What was the second equation? 6x plus 3y equals 36. I have to put both of these into slopo-intercepto formo. The first one is a little easier. Second one takes some work. I'm going to go to Trudy Rudy. Trudy Rudy. Rudely. I want to write the first one in slope-intercept form, so tell me, Rudy, what do I got to do?
The first one?
Write the first one. This one right here, one on the top.
So you have to get the x to the other side.
Okay. How do I get the x to the other side?
You put a 1 in front of it, and then no wait.
I don't have to put a 1 in front of it. I could just. This is a positive x. The opposite of that is a
Negative.
negative x. So I subtract x from both sides, and I'm going to end up with y is equal to negative x plus 8. I don't know why it's writing weird all of a sudden, but y equals negative x plus 8. We know that there's an invisible coefficient here. That's negative 1. First one is done. Second one, everyone's looking at this one like, please don't call on me. Please don't call on me. But hold on, actually I think I called on you, but I don't think I've called on Sydney. Sydney! You don't get the easy one. Sydney, what are we doing? Right here. What am I doing? Yes, we are doing the problem. We've been doing that for the last 90 minutes. What am I doing right here in order to get this in slope intercept form? What happened?
They tell you to do?
You tell, yes, you tell me what to do.
Well, you minus the mass is what I have here.
Okay. Minus 6x, minus 6x, and these will cancel, and I'm going to have, okay, 3y equals negative 6x
Oh my god.
plus 36. Okay, so we've gotten to that point. The question is, do I have y alone over here now?
No.
No, I have to do something. Sydney, what do I do?
You divide 3 double sides.
I divide, and I'm looking, there's something wrong with the board, but anyway. I divide both sides by not 3x, but just 3, right, because that's the coefficient. And I'm going to end up with y equals, yeah, negative 2x plus 12. Perfect. I ran out of space there, but you guys get the idea. Y equals negative 2x plus 12. Perfect. We moved the x over. We got rid of the coefficient next to y. Now we can graph both of these equations. I have y equals negative 1x plus 8. I have y equals negative 2x plus 12. I can graph these. I can get a solution. I can figure out how much Ocho Amigos Incorporated El Chico Magnifico buy. You had a question, Sid?
No, I want to take
It's very correct. No, I have a question. Where's my ticket? Pass that back. Galco?
Nice.
Looking at the first equation. Oh, you had a question? What's up?
How did you get 12?
How did I get 12? What is 36 divided by 3? 12! 12. That's how I got 12. Easy question, easy answer. Calco! Oh, you have a question?
No, we didn't get it.
Oh, Calco's going to do the first one? You can help me with the second one. All right. Calco, y-intercept. First point I must always graph is the y-intercept. What's the y-intercept for the top equation?
8.
8. Now, here's where you must be careful. Look at this graph. What's it going up by?
2.
2s. 2, 4, 6, 8. That's going to change how you graph it. Make sure you always look at the graph. So, I go to 8. Now, my slope here is negative 1. So, I'm going to be going as a fraction that is negative 1 over 1. Because this goes down up by 2s, I have to be careful. So, I'm going to go down 1 over 1, but there's no lattice point there, so I'll go down another 1 over 1. I end up there, and there, and there, and there. That's what it would look. I skipped a couple points here because they weren't on the intersections of the graph, but that is the same thing as going down 1 and right 1. What's up? And actually, Fiamma's got the other one, so I'll connect these with a line. And then I have to go in and graph the other one. So, Fiamma, what's the y-intercept for this equation? 12. The good thing is this one actually goes by 2s. So it's negative 2, comma 1, but here's where you got to be careful. Although we're going down 2, I'm only going right 1. Notice that this is also going up by 2s. So I want you guys to look here because you might have done this wrong. You're going down 2, right 1. 1 is right in the middle. Down 2, right 1. Down 2, right 1. Down 2, right 1. But what's wrong here? Did I start at the right point? No, I didn't. I got to go back up to 12. You know how many times I see that when people graph. So I go down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1, down 2, right 1, down 2, right 1. If you're confused as to why the points are there, it's because this x-axis is going up by what? What's it going up by? 2s. So when I go right one spot is in the middle. That's 1, 2, 3, 4, 5, 6, so on and so forth. You have to be very careful when you graph these. Because I'm going right just one spot, I'm not going to go a whole line over. I'm only going halfway. That's 1. Then 2, then 3, then 4, then 5, then 6. But I see my point of intersection. Hopefully we got the right answer. And what was your answer, Fiamma? Where do they intersect?
4,
At 4, comma 4, which means in the context of this problem, Shimon, how many hats did they buy? 4. And how many shirts did they buy? 4. They bought 4 caps, 4 hats. And that needs to appear. And that is your answer. Thank you, Shimon. Thank you, thank you. What's up? Question?
Wait, okay, for the first line,
Quiet, please.
this is going down by 1.
It's going down 1, right 1. Guys, hold on 1 second, please, because somebody has a question, and I can't hear it. So it was going down 1, right 1.
Wouldn't you go halfway like you did before?
I did, what I said is I skipped over those points. So yeah, there's a point here, and 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 here, And you get all those points. I just went 2 and 2. Good catch though. What's up? Question in the back? Are we good on this? All right, then. 4, 3, 2, 1 on this.